as we did a bit of discussion on Sunday towards the end of the lecture, we now will be focusing on software architecture for next few lectures. And uh, architecture is a very important fundamental part of the design, the bigger design discussion. And we will be looking at what is an architecture and what are different styles and what you can really do, which ones are the most appropriate ones, which different scenarios. Of course, we will be looking at fundamentals of architectural concepts, and we'll be looking at some of those styles which are popular in the industry. We won't be able to cover all of them because this is, in this course, we also have to move on and then think about good design decisions, package designs, class diagram designing, design patterns. So typically I cover a lot more details of architectures in 416, which is the elective course. But, we will be able to cover the basics and fundamentals of architectures and some very interesting examples of architectures in 316 as well, so that you are ready for your next design tasks and careers and so on and so forth. So we'll be defining architecture more formally later, and then we'll be looking at architecture style as a concept. So in this half of the lecture, I'll not be really giving you formal definitions, but I'm actually going to try and build a case for you guys, try to make sure that we realize what's the role of an architecture is, and what it really mean by style here. Now, if you recall the story I shared with you guys, like an analogy I shared with you guys, it's not more like a story, it's like an analogy where I shared that you have one-story house and then you decide to expand it and make a two-story house. Hence, you come up with a new engineering problem here that you need stairs, right? And then you move on to five-story house, then you realize that stairs are no more a valid solution. You need to think out of box again, and you come up with a solution of elevators and so on and so forth. And you make complex buildings and keep doing it like Burj Al Khalifa and so on and so forth. So there's a lot of similarity between the way the architectures, the buildings are, and the way we develop applications from a software architecture perspective. Like in buildings, they have requirements, then they do some kind of design, then they construct and use it. We basically, not identically, but very similar. Similarly, we do the same thing for software applications. We have requirements, then we design them, then we develop them, then we test them, and then use them. So there are certain very obvious parallels between the architectures of the buildings and or civil engineering and the software architectures, is that at the end of the day, in both cases, we are trying to make a product which is basically satisfies customer needs. So if you are an architect, you're trying to develop a building which satisfies your customers' requirements. Similarly, we are also trying to make an application which satisfies customer requirements. Like in civil engineering, they have specialist labors. This means they have people who are like specialists in electrical work, in paint, in flooring, in woodwork, so on and so forth. Similarly, we have people who are expert in, for example, requirement analysis, testing, designing, architectures, and like in buildings or typical, civil engineering products, they design the product and they look from different angles and different perspectives. Like, if you have a building, you will have a design from outside, you will have a design of exterior, interior, then within interior, you can actually have different floors. You can even think about design of an actual one specific room, so on and so forth. We also do the same thing. We design the applications, and then we start with very high level decisions of the structure of the system, then we can really dig into it. So there are a lot of parallels between the way architecture is done in a civil engineering project and the way we do it. Similarly, like them, We always have, plans, schedules, and milestones, and we basically go on and review them and make sure that the project is being developed on time. So uh, there are a bit more deeper parallels as well, right? So which is like the architecture is different but linked to the structure of the system. In other words, uh, in our case, the architecture, like in civil engineering projects, the architecture kind of drives the way the structure of the building will be or structure of a bridge will be. Similarly, we have in software engineering different architectural styles or forms, and basically, which actually kind of tells you the structure of the software application you're developing. Properties of the structure are induced by the design of an architecture. Like, for example, if you have bridge, you can have so many different kind of bridges, right? You can have a bridge which has pillars. You have a bridge which has hangings. So there's no bridge, no pillars in it. It's all hanging bridge with the help of cables. So the properties of that structure are coming from the architectural decision you have taken. Similarly, for our case, the properties or the structural properties of the software application will actually come from the architecture you have selected for your application. Like if you select a client server architecture, then, or if you select a peer-to-peer architecture, or if you select an event-based architecture, each one of these architecture style has its own structural properties. And your overall design is actually driven by those decisions. Like if you select a client server architecture, it will mean that you will have at least one server. If you select a peer-to-peer architecture, it means there is no such thing as one central server, and so on and so forth. Everybody's on board with me on this point.
Yes.
All good, right?
Right.
Right.
Okay, so let me continue. Now, of course, like in civil engineering, and they actually have a discipline called architecture or architectural engineers, we have something called software architects as well. It is one of the very important role in the industry, in the market, and probably software architects are one of the highest paid jobs in the market as well. And the reason is software architects actually, they they are the main driving force, the lead of the structure of the system. And especially when you go to an enterprise level, enterprise architects are actually, are the ones who are technically leading the whole project. The project managers are more importantly focusing on the schedules. They're focusing on the costs, the budgets, and all of that stuff. But it's the software architects who are actually the technical lead of the project. And I see you guys, inshallah, being software architects down the road. Of course, after this, after getting through 316, or even you take 416, you will have the fundamentals of the architectural concept, but I don't see you will become architect immediately, because for you to become architects, you need to have a bit of more industrial experience about, programming and different systems and so on and so forth. But it is a very important, distinct role. It's a key role in the industry, probably one of the highest paid roles when it comes to software engineering, different jobs. And I see most of you guys becoming software architects down the road. It's a lead role. So I like your special attention now here. I'm going to make a statement, a bit of a bold statement here. And I'm going to see what you understand from the statement. What I'm saying here is that process, and what I mean by process means software process. Software process is not as important as architecture. I'm kind of making a very, very bold statement. What do you make of this statement? What do you understand from this statement?
that software architecture is more important than software process, maybe.
Yes,
Victor,
yes. Go ahead,
isn't
please.
isn't architecture as a part of the software process? The designing of the architecture, I mean.
Okay, okay, okay. So basically, is it architecture part of the process, right?
Yeah.
Good. Yeah, this is where my question is. This is where I'm actually making a very bold statement here. This is where I'm kind of challenging us. You're right, absolutely. It's part of the process. Yes.
So it's the most important part of the process, is it?
Yes, 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 yes. Anybody
Mm,
else take on it?
I guess maybe architecture is important because it's affecting the end result or the product or the software product more than the process does. Because the process is like how we are maybe delivering the end product. I don't know. I understand it that way.
Which is fine. Absolutely, you're spot on. Actually, this is the way. This is my. This is my. Yeah. This is my message. Anybody else would like to make a comment here? What he understands from the statements we have in front of us now? There, I'm saying the software process is, not as important as an architecture. And I'm saying, process is a mean, not an end. Nobody else would like to make a comment here? I'd love to hear from someone else, please. That what he understands from this. Probably nobody's interested, right? I hope everybody is at least with me here, right? You're not just logged in, right?
Yeah, with you.
Yes, of course.
I'm worried that we are only logged in.
No, we are with you,
No, we
Doctor,
are.
but I think what my colleague says is enough. Yeah.
Yeah, is enough. Yes, yes, yes. And it's true. Actually, it's true.
It is not
Yes.
clear what you mean exactly by the process. How do you
So,
differentiate between the process and the designing architecture?
yes, yes. No, let me comment on it now. So, see, from 205 days and, and even in 215, when we were talking about software processes, we say, you have a waterfall model, and then you have an incremental model, and you have, the RUP models, processes, and so on and so forth. And of course, as one of our colleagues just said, that yes, architecture is part of the process. It's one of the phases of the software development life cycle, which is absolutely true. What I'm trying to convey here is that, of course, when you're gonna come to when you went through a requirements course, the instructor will say requirements is the most important thing, and now I'm teaching you design, so I'm saying design is the most important thing, and when inshallah you will take 326, the instructor will say the testing is the most important thing. Well, all of them are important in their own perspective. uh, the role of an architecture is crucial here, so in a sense, because your system structure depends on it. And it is the decision of the architecture which will, structure the application, the way you will develop the application, and this can make or break your application. So software process is important. We're not saying that we should not know waterfall or increment or RUP or agile or any of that. They are important. They are just a mechanism or a mean for us to develop products. But so in other words, we should not be focusing too much on saying, because I'm following a certain process, this means, I will not think about architecture because I'm following a waterfall process. In theory, this is the case, by the way. In theory, it says, since I'm talking about waterfall process, I'm not going to think about any architectural decision or any of that stuff till I come to design, which is true from a process perspective. But to be honest, in reality, it doesn't work this way. And we start relying on our experience to think about architectures. And the reason is because this is the fundamental thing of the application. So your architecture is gonna make the structure of the applications. It's gonna give you the properties or the results you're looking for. So the good news for us here is that, like other disciplines, our architectural discipline has also matured over the years, because we have developed so many different products in the industry that in the industry now we have a catalog of certain architectural styles. And like going back to my example of 1-story house, 2-story house, 5-story building, these styles, these catalogs are there based on the problem given to you, the context given to you. Most of the times you will just select the one which is the most appropriate one and you will use them. There will be cases where you might have to go and come up with a solution, and sometimes your solution will be to mix these different basic styles. And of course, in complex applications, you might have to think completely out of the box and come up with a brand new solution, because the existing styles or combination of these styles doesn't solve your problem. Everybody's on board with me on this statement? Haven't gone into details about the architecture yet. I haven't really given you any definition, and I'm not going to give you a definition soon as well. I want you to first realize what exactly is architecture and why we are so much concerned about it, and why a decision taken at this role will really impact the overall structure of the application. Because if you recall, before I move on to the next one, if you recall in the very first lecture, I had this diagram, right, where I had requirements and then I had architecture and then I had detailed design, right? And of course, your architecture drives your detailed design. Of course, it satisfies the requirements, right? And we know that, based on your architectural style decision, either you're going to be able to satisfy the non-functional requirements, and most importantly, they are usually satisfied based on your architectural design decisions, or you will either make it or break it. So we are focusing here, guys. We are worried about, and we're talking about this phase now. Okay. Now, how to do it? What are those styles? Just bear with me. We will talk about them very soon. Okay. Now, let me take this discussion to the next level now. You guys are so much familiar. Actually, you guys are born with an age of internet, right? Isn't it? So, one of the most fundamental platform for software development is the web. Now, my question is, imagine, because all of you guys are software engineers, I want you to go on and somehow explain what an internet is to what a web is to let's say a 4-year-old or a 5-year-old child. How are you going to explain what web is to him? Give it a go.
Maybe I would say a large library, maybe.
Yeah, absolutely. Maybe a large library. Anybody else would like to explain how you're going to explain web to a 4-year-old, 5-year-old child?
Digital world. It's like a world does not has not physical exist.
It has no physical existence. Okay, fair enough. Absolutely. Anybody else? Yes, Akbar, go ahead.
Yes, I think I'd like to say to him that it's big machines are separated and connected by wires, contain some information. That's it.
Absolutely. So if we can all explain, or we can all try to explain this from a different perspective, right? Anybody else would like to give it a go?
It's a virtual place where people can share information all over the world.
Yeah, virtual platform where people are sharing information, right? Okay, so now let me ask you this question. If I ask you now, please go ahead and go and visit a high school student class. And nowadays, pretty much all high school students, take some kind of computer course or some kind of computer information in their high school anyway. So if you have to explain web to him, what you're gonna do now? How are you gonna explain to him now? Because his understanding is different from a 4-year-old now, right?
Right.
Go ahead.
So now I'll tell him that it's a number of computers or many computers around the world sharing and exchanging information through networks such as Wi-Fi or the cables around the world.
Yeah, so basically now you can use the word network to him because you understand that he will understand it, right? Yes. And he can comprehend it, while a 4-year could not really understand what the network is, right? Anybody else would like to see how they're gonna explain the web to a high school student now?
I think I will stick with my first explain because I think it works with both of them.
Fair enough. Fair enough. Fair enough. Couple of more, please. I'm pretty sure you guys can explain the internet in a different way as well.
I don't know. It's just a number of computers. They are just connected to each other, and they are transforming data. That's it.
Yeah, so they're transforming
nothing more, and that's the internet actually.
Fair enough. Now, let me ask you a last question on this series of questions I had. The last question is, now, for example, you are approached by a customer now, right? And he wants you to develop an e-commerce application. He wants to sell products. Now, how are you going to explain, the structure of your application and the role of the internet in it to him? And he's not a technical guy. He knows his business. He's a very experienced businessman, right? So, for example, he owns, one of the chains. So how are you going to do that?
Do what exactly, Doctor? I didn't get it. Like,
explain the structure of the application.
Like how I'm gonna do it, or what?
Yes, or what it will do, or how it will look like.
Okay, yeah.
I'll start by the functions. Depend on what he wants. Then I will give him a brief about the interface of the application he wants and how it would communicate with other external systems. So you could have a clear picture of what will happen and the means of it, without giving any technical terms that would not be understood by him.
Fair enough. Now his perspective is different, and he's interested in payments, all of that stuff, user interface. So yes, absolutely. Anybody else?
I would show him an example, like if he wants e-commerce, I would show him Amazon and explain what I think on Amazon, like this functionality would be here and so on.
Yes, and more focus. I want you guys to focus with me here on the internet role, right? That is, if it's an Amazon, what's the role of an internet here?
Internet would contain Amazon and other e-commerce.
Absolutely, absolutely.
E-commerce websites.
Yes. Akbar, you gonna say something?
Yes, but I'm not sure if I want to say it or not. I think I will tell him that how everything is connected to each other. Like I'll tell him this information will go here and this will go here, then it will go to that database. Database is on blah blah blah, and I will explain to him with simple terms. Like I will say to him that your information will go to the cloud. The cloud is basically a server, and this and that will happen there with a simple terms.
Absolutely spot on. So see, all of this is, this is absolutely right. So the reason I'm asking this question is actually, maybe I can put them on a slide. I had these ones, so we already done this one. We already had done this one, like, we are asking us to explain. Now, the reason is that we can explain the internet at different levels, right? We can explain the same thing to a 4-year-old child, and then our level of description is different to a high school student, to a businessman, right? So will you accept this as an explanation? Like, will you say that, yes, it's explaining web. It doesn't have details in it, but it tells me what a web is. Will you agree with me on this diagram?
No.
Okay. Go for it. Criticize it.
Yes, there is no clear terms about what will happen, and no explanation of these arrows and what it does. Also, these boxes, what does it represent? So it's very.
So maybe I'll say these boxes are web pages.
Okay. And what does the arrows?
Arrows are the information sharing, or the way they connect to each other.
Yes, it maybe explain the web, but not the big picture or the whole picture.
Exactly. So it does explain, but it's not complete. It's not detailed, right?
Yes.
Yes,
absolutely.
Doctor. I think it's explained in a good way, really. If I will talk while I'm showing it.
Yeah.
So I can tell him the A is the machine in that location, and the arrow is, for example, a wire from Europa to Asia or something like that.
Exactly. Now, what about this one then?
Yes, this one is much clearer.
It's more better, more technical,
yes,
right?
More technical, right?
And it kind of shows the servers and the clients and the network, right?
Yes, absolutely.
Absolutely. And what about this one then?
It's much more deep in details, like it has more details.
It has more details, and it's talking about the internals of the websites and even the protocols, right? How the data is going back and forth and so on and so forth, right?
Right.
And you can even go to next level of detail. Then you can say, all the web applications, they have, the URLs, and it's actually, the information, and, URLs are used to identify the machine. And you can, even go to next level and you say, communications takes place between clients, and we use web browsers, right? And you can even go to next level and you say we use HTML to develop these ones, or we use JavaScript to develop these applications, and we use HTTP or HTTPS, and we have different network protocols, and we use all of that stuff to share information, right? And then we can even talk about, these applications are stateless interactions and so on and so forth. So you can move the explanation of your web from such a high level, maybe for a high school student or maybe a 4-year-old kid, to this level of detail, to this level of detail, to a lot of significant level of details here, right? We're still talking about the same thing here. We're still talking about the internet. And this leads me to the next question. Where is the source code of the internet? I want to go and change the source code of an internet. Where is the source code of an internet?
So what?
Where is the source code? I want to go and change it.
There is no such a thing. I don't know.
Yeah, there's no such a thing, right? Then what it is?
It's not a software.
It's not software. But browsers are there. Network protocols are there. What is the fundamental property of the way we organize the internet? What is the fundamental property here? Of course, they are source codes, right? Isn't it?
Yeah.
Because you write HTML pages, you write JavaScript, you write e-commerce applications.
It's not owned by one company. It's shared all the world.
It's shared across the world.
The source code of a web page, it will be saved in a server. So if we want to look at the page, we will call the server.
Yes, and everyone has his own servers, or everybody has his own hosting sites, and so on and so forth, right?
Yes.
Yes.
All right. So this is, if someone asks you, I want to go and have a look at the source code, there is no such thing as one source code for the web. It's all separated. So architecturally, this is our decision as software engineers and computer scientists, that we have come up with a structure of the web which is actually, the code is completely separated from it. It is highly distributed, right? It's highly distributed, decentralized, right? This is a decision you guys have taken as that this is how the internet will be for its obvious reasons, right? So there is no such thing as a one single code which implements this architecture. There's no such thing at all. You have different browsers, and you have different pieces of code which implement these browsers, and you can go on and write your own pages and so on and so forth. So you can go on and explain your web from this perspective to this perspective to this perspective to more details like having browsers, and you say that there is no such thing as a source code. We have basically, we have a highly decentralized structure. Everybody has its own servers, and you basically have your own browsers, and you can have your own pages, and so on and so forth. This whole structure actually, is based on the architecture you have decided for your application, which is the web. And of course, it has different stylistic constraints, right? Because one of the constraints is that it's highly decentralized, highly distributed. There's no such thing as one piece of server where you have, the internet's source code, right? No one company owns it. This is just the structure. This is the way you have come up with the structure. And as a result of that architecture style, you have introduced certain constraints. Everybody on board with me on this? That's what's happening here, right?
Yes, doctor, yes.
So see, will you agree with me on this statement?
Yes, I agree.
Absolutely. There is no other way to explain internet but to explain it in an architectural terms, right? Yes, I can explain it at different levels depending on what my audience are. I can, explain it in very high, shallow, like this slide, or more details, or even more details, right? And I can keep going into details about all the protocols and everything. But at the end of the day, I can only explain one of the largest and probably and the most successful and an application which has completely revolutionized the industry and the world only from an architectural perspective. And it's the most successful one in the world because the way we selected the architecture, it allows people to go on and add stuff in it, delete stuff in it, remove stuff in it. It gives, so everybody follows a certain basic protocol, which are the constraints, but then you are free to do whatever you want to do. This is a style you came up with as an industry, right? And you can only understand them, you can only explain them from a purely architectural perspective. I hope I'm able to convey the message of the role of an architecture here. And how critical they are. And your applications make or break depends on it. Now, of course, as we move along, we'll formally define architecture. We'll formally look at styles. We'll all, we'll look at which style is better than the others, and so on and so forth. We'll all do that. But I hope everybody is comfortable with it.
Yes.
Okay, so let's move on. Now what's happening here? Again, I'll fall back to my one-story house building example, or two-story and apartment buildings and so on and so forth example. So see, the architectural decisions, are not taken, and this is where my statement was, it's not the process, it's the architecture which is, important, is that you take your architectural decisions usually in a bit of an iterative process. Now, if you're more experienced as an architect, probably by looking at a very high level requirements, because this is very generic, you will be able to pick a style which will be appropriate for an application. But sometimes for more complex applications, you will have to go back and forth and really understand the requirements in a bit more detail before you can actually go on and finalize your architectural style. Right? And of course, as you move along in the requirements, of course, you are independent of the implementation. But the moment you start thinking about architectures, you start becoming what I call dependent on the implementation as well, right? Everybody's comfortable with what I'm saying here?
Yes.
Cool.
Kinda.
Yeah, kind of. It's okay. Let me
Doctor,
dig into. Yes, please go ahead.
Why isn't it one go? Like I should understand the whole requirements and then go to the architecture.
It's a good one. I was waiting for this one. Absolutely, it's a good one. Now, see what happens in reality of the world is that if you look at this is where the process statement comes, right? Now, if you say that I'm going to use a waterfall process, right? This means, or even others, you say, I'm going to look at the requirements first. I'm going to really try to understand the requirements. And then I'm going to think about the architecture, because as I was taught in the requirements course, in the requirements, I'm only supposed to think about what the system is doing, not how the system will be doing, right?
Yes.
But in reality, from your experiences even, don't you think about, based on the first look at the structure of the system, because of your experience with some similar systems, you have some kind of a visualization about the architecture of this new application?
Yeah, of course. I think about the coding methods also.
Exactly.
So, yeah, I mean, it's natural. Yeah.
It's natural. That's the spot on. This is the word I was about to use. It's natural. It's natural because because, for example, I asked you guys go on and, for example, a Prince Muhammad University has contacted you and they want you to have a course registration system. Well, of course, the way you're going to try and understand the course registration system, and the way you're going to first of all try to visualize is based on the experience you have seen here at the KFUPM, right? And this is true in the normal life of development and software engineering tasks as well, that you're going to rely on your experience. I'm not saying that you focus based on experience, you make a final call. No, you never do that, but you have a starting point, and it's very natural. You have in your subconscious these decisions, these visualizations, these experiences. And that's why for a simple application, or you're so experienced, probably will be able to take an architectural decision in the beginning. But in reality, the world, you need to dig and think about and carefully understand these requirements and say, oh, okay, for such systems, probably, out of these 2 styles or 3 styles, this is the most appropriate one. Of course, it's always natural that, for example, if there are, for example, say 10 different basic architectural styles. For a given product, maybe 2 or 3 are probably the most appropriate ones, right? It is never going to be the case that all 10 are applicable here.
Yes.
So basically, we go through this process of going back and forth to kind of, streamline it. And as you move along, for example, for sure, you take this journey, you start thinking about implementation, you start thinking about protocols, you start thinking about, what kind of technologies I have. Does my technology support this solution or not, right?
Yes. But what I meant, like the iterations. Does it mean that I read a little bit of requirements and I go to architect and then go back?
Okay. That's a good question. No. Yeah. No. It doesn't mean really that. It depends on, it doesn't really mean that way. Actually, I will say this very shortly. So if you just bear with me, I'm going to comment on this observation you have, right?
Okay, fine. Yeah.
This is absolutely a spot on observation, actually. So at the end of the day, and I'm going to comment it in a minute, inshallah. So basically, we know that design, is an activity which is basically, architecture is part of the design. There's no doubt about it. And it is actually, which basically help us create the architecture of our system, the structure of our application. And these decisions typically, helps us design the structure of the application. Like, for example, whether I have one server and multiple clients, whether I have no servers at all. A client is actually, both server and, so our device is both server and client. It's an event bus I have, many other styles, mobile, and so on and so forth. So basically, your architectural decisions help you decide your structure. It helps you identify the key components of your application and their interaction. So these are the 3 things your architectural decisions cover. Formally, not today, but inshallah on Thursday, I'm going to formally define architecture. I'm going to formally define component. I'm going to formally define what I mean by interaction, which we call them connectors. Okay. And, we have something called principal design decisions. And I'm saying architecture represents the set of principal design decisions. So when you look at this one, at least to me, this thing comes to my mind, that this means I have a set of design decisions. Okay. And some of these design decisions are principal in nature. Do you agree with me? Based on this statement.
Can you please repeat?
Yes. So I'm saying architectural denotes the set of principal design decisions. Right. So I'm actually taking this to the next level and this saying that the moment I'm putting a word principal design decision, this means that I have many design decisions during the development of the system, and some of them are principal design decisions.
Yes, exactly. I agree.
Yes.
Yes.
Now, the question is, what is a principal design decision?
Like the architecture of the system, I think. Like if you want the system to be embedded or like this.
Yes. So yes. Let's yes, Riyad, Faya. Yes, go ahead, please.
Fadi, okay.
Yes, let's Fadi. Yes.
A decision maybe like separating a database from the UI. Maybe is that a design decision? I don't know.
Yeah, absolutely. This is a design decision, and it's going to impact the structure of the system, right?
Yeah.
Yes, yes, absolutely.
Of course.
Yes. Now, let's ask a question here. Can we think of a design decision which does not impact the structure of the system?
I didn't think so. We can't.
Think about it. Think what are different design decisions you take. And I'm telling you that some of them are principal design decisions and others are not principal design decisions. They are design decisions, all are design decisions, but there are certain design decisions which impact the structure of the application. And then there are other design decisions which are design decisions, but they don't impact the overall structure of the application.
Maybe the platform that you are gonna develop. I mean, in which platform you are gonna develop the application.
Maybe it can impact your structure, maybe, because certain programming languages support different kind of, or certain, because for example, certain frameworks does change the impact of structure of the application. Yes, they do.
Yeah, exactly.
Yeah. Think deeply. Think about design decision.
User interface design does not impact the structure.
Yeah, so maybe the layout, if I put your words, layout of the user interface, colors, right? They are design decisions in a sense, but they really don't really change the structure, right? What about the selection of algorithms? For example, I'm going to use a bubble sort or a quick sort or something like this, right? Well, they are design decisions, but they really don't change the structure, right?
Yes.
Or even the use of inheritance or use of certain, interfaces or abstract classes. They are all design decisions, but they don't really change the structure of the application, correct?
Correct.
I think we're running out of time, isn't it? We only have 1 minute, so I think I'll stop it here. Only one slide to go, but inshallah, I think it will not be fair to talk about it, because this is where I'll try to answer the question I had a minute ago. So probably I'll stop it here, and there's only one slide to go. I'll talk about this on Thursday. So let me stop the recording now. The assessment, inshallah, will happen on Friday, and